In this video, we're going to have a look at how to calculate missing angles in triangles. We essentially need to know that angles in triangles sum to 180 degrees, just like in a straight line for adjacent angles. So if we look at this triangle here, we've got two angles. We know that all three angles add up to 180. They sum to 180. So if we add the two angles that we have, 37 and 22, that's going to make 59. So these two angles make 59, so the last angle must be a number that takes the whole triangle up to 180. So to figure out what that is, we're going to 180, subtract 59, I'm going to take away 50, I'm going to take away 9, and I'm going to get 121 degrees. So x is 121 degrees. The angles in a triangle add up to 180. And question 2, we've got a different style of triangle because we've got this box here. And recall, this box means 90 degrees. The angles in a triangle sum to 180. So if we add the two angles that we have, if we do 90 degrees plus 41 degrees, we're going to get 131 degrees. And to figure out the value of x, we can subtract that from 180 because they add up to 180. And we should find the angle x is 49 degrees. We're going to look at a special style of triangle now. We've obviously got different styles. We've got scalene, right-angled, equilateral, isosceles. We're going to examine isosceles triangles with this next little set of questions. We know it's an isosceles triangle. We know a triangle is an isosceles triangle if it has two dashes on it. If it's got two dashes on it, it means that those two sides are the same length. So for example, if this was 11 centimetres, the side with the other dash would also be 11 centimetres. But what's nice about isosceles triangles is not only do they have equal sides in two of them, they also have two equal angles. What I like to do is I like to draw wee arrows at the end of my dashes and see where those arrows point to. Those angles are equal. So if one of the arrows points to a 52, the other arrow must also point to a 52. And if I want to work out this angle at the top here, well, I know that the angles need to add up to 180. So if we do 52 plus 52, we'll get 104. And if we subtract that from 180, I think that's going to be 76 degrees. So we can say that this person up here is going to have to be 76 degrees. Let's have a look at example 4. In example 4, once again, we have an isosceles triangle. We know it's an isosceles triangle because they've got the two dashes here. So those two sides, the side on the left and along the bottom, are equal. And it also means that the angles opposite those sides are the same. I'm going to add in those arrows. So if we know one of the arrows, we know that this one here is 71, therefore the other one must also be 71 degrees. To work out the missing angle, we can add them together. I think that's 142 degrees. And if we subtract that from 180, we're going to get 38 degrees. So up here, we're going to have 38 degrees. Let's have a look at example 5. One more example after example 5. We've got an isosceles triangle. How do we know it's isosceles? We know it's isosceles because it's got the two dashes. Those two sides are the same. If those two sides are the same, the angles that the arrows point to must also be the same. But do you see that that doesn't necessarily mean that they're both going to be 80? Okay? Neither of them is going to be 80. We know that the angles add up to 180. So see if we subtract 80 from 180, we're going to be left with 100. But if you put 100 here and 100 here, you would be incorrect because the angles in this case are not adding up to 180. What we need to do is we subtract in this case from 180 and then we need to divide that value by 2. 100 divided by 2 is 50 degrees. If this is 50 with this arrow, then this arrow must also point to a 50-degree angle. And hopefully you can now see that those angles inside the triangle add up to 180. Finally, one last example. This isn't an isosceles triangle yet. There's also a bit attached to it. Let's put our dashes in. Here's a dash, and let's put another dash here. And let's say that in this question we're given this angle here. Let's say that this angle up here is 124 degrees and we want to figure out the other three. Well, what do we know? we know, I'll do this, and we know that this angle here is the same as this angle here. So if we know this one, that will give us this one. And then we can do some maths to work out the one in the bottom right. But we don't know this one at the top here. It might be more helpful if we zoom right in to examine this part here. Do you notice that when we zoom in, it looks like a straight line question because we've got two angles, two adjacent angles on a straight line. And adjacent angles on a straight line, angles next to each other on a straight line, add up to be 180 degrees. So if we subtract 124 from 180, that's going to give us 56 degrees. So therefore, this angle in here must be 56 degrees. Now I'm going to zoom back out now to the bigger picture. If this angle is 56, the other arrow must also be 56. And we know that the angles inside a triangle add up to 180. So we know two of them. We're going to add together the two inside the triangle. It's important we add the ones that are inside the triangle. And if we subtract that from 180, I think we're going to get 68 degrees. So this angle in here is 68 degrees. Okay, so there's a few examples on looking at angles and triangles, and we looked a wee bit more closely at isosceles triangles in the last 4. Thank you.